The Coleman family had their bill at a restaurant reduced by $7.50 because of a special discount. They left a tip of $8.90, which was 20% of the reduced amount. How much was their bill before the discount? We are still using the distributive property, so we want an equation. There are other ways to do this. If you solve this in some other way and get the right answer, that's fine. I'm just going to show you what we're looking for with distributive property, or how you would use the distributive property with this. Okay, so let's call the original amount, because that's what we're looking for. We're going to call the original amount x. That's our original amount. And then let's see if we can write an equation using everything. Okay, so Coleman family, not really pertinent information. I mean, it's nice that we know the family's name, but not necessary. And bill restaurant reduced by $7.50. So there was the original amount. It was reduced by $7.50, so minus $7.50. And they left a tip of $8.90, which was 20% of the reduced amount. So we want to multiply this by 20%, which 0.20, that's 20 over 100, so that's 20%. And we know that that is equal to $8.90. Okay, so there's several ways we could go about this. The first thing, though, that I want to do is I don't really want to work with the decimals. So I'm going to use our trick of multiplying everything by the least significant value, and then I'll go through the operations from there. But in order to do that, we could do two things. We could distribute first and then do that. I'm going to multiply everything first and then distribute. But let's look at it this way. So least significant value, or digit, we do have these zeros that are in the hundredths place. And we could multiply by 100. It won't give us a wrong answer. We'll just be working with bigger numbers than we have to work with. Because it's a zero, it doesn't actually have any value. 8.9 is the same thing as 8.90, and 7.5, same thing as 7.50, and 0.2 is the same thing as 0.20. We're using money, and that's the only reason that we keep the zeros. So let's multiply everything by 10, and that will get rid of the decimals. So if we multiply everything by 10, we're going to multiply this side by 10, and we're going to multiply this side by 10. On this side, 10 times 0.2, that gives us 2. Now, you might be tempted to multiply by everything inside of the parentheses, but because this is being multiplied by everything inside of the parentheses, we're only going to multiply the 10 by this. So everything inside the parentheses as of right now is going to stay the same. Okay, so that's what we ended up with. And now we could do one of two things. We could divide both sides by 2, and that would then take away our parentheses. But we want to practice distributing, so we're going to distribute this 2 through the parentheses. So 2 times x gives me 2x. 2 times negative 750 is negative $15, and that is equal to $89. We're now going to add $15 to both sides because we don't want the 15 on the same side as the x. And that's going to give me 2x is equal to, that gives me a 4, carry my 1, $104. So if 2x equals 104, and I now divide both sides by 2, then the cost of the original meal was $52. And that's how you do that.